when we have a function, we put in a value of x, we put it into kind of our f, and we get out a value of y. And the inverse then goes the opposite way. So if I want to be putting 3/2 into my inverse and working out what I get, then this is actually the same as setting my original function equal to 3/2. I don't actually need to find the inverse here. So solve 8x plus 5 over 2x plus 3 equals 3/2. I'm going to explain this in a second way before I do this. So another way to do it is to say, right, I'm going to let y equal the inverse function of 3/2. And then I can apply the function to both sides. So therefore, f of y is going to be f of the inverse of 3/2. But if you do the function and its inverse, they actually just cancel out. And then you can see again, I'm interested in where my function is equal to 3/2. So I've set it equal to 3/2, and I'm going to solve it. I'm going to cross multiply, so times through by 2, 16x plus 10, and then times through by 2x plus 3. That will give me 6x plus 9. Therefore, 10x is equal to minus 1, x is equal to minus 1 over 10. And that's going to be my answer, minus equals minus 1 over 10. We're then asked to show that the function can be written like this. In theory, you could do a partial fractions approach, kind of set it identical to 8x plus 5. There is a quicker way. In fact, I'm going to do it the quicker way. We can do a polynomial division. 2x plus 3 divided into 8x plus 5. So 2x is into 8x, go 4. Multiply back through, 8x plus 12. This leaves us a remainder of minus 7. So the 4 is called the quotient, it's what we've sort of got as our whole number. The minus 7 we haven't actually divided by 2x plus 3, so that's why it's going to become, all right, there is a plus there. So normally I would write minus 7 over 2x plus 3, but to put it in the form that they've asked for, I don't think it's going to matter in terms of the mark scheme. That is my answer. Function g is then defined as g of x is 16 minus x squared, but over this restricted domain, 0 to 4, state the range of the inverse. Actually, this is very quick. The range of the inverse is essentially the same as the domain of the original function. So it's just going to be 0 less than or equal to the inverse less than or equal to 4. If you look back at the diagram up here, you can see that. So, the domain is what we're putting in here for the original function. And then we're getting out some new values, which is our range. When we go the opposite way, that range becomes the domain. Like that 3/2, for example, is what we're putting in. And then you get out your range of your inverse, but that is going to be the same as the domain of the original function. Remember, they're just going opposite ways. I've got to be honest, when I did this question, I also really wanted to write down the range of g of x. I just think it's quite a good idea. So I'm going to do a little sketch of it. So 16 minus x squared looks like this, but I'm only interested in 0 to 4. And actually, it's just going to be this bit here. So it's going to be between 16 and 0, actually, because this value is 16 when x is 0, and this value is 0 when x is 4, and you can see it's just a decreasing function over this part. So I wrote that in 0 less than or equal to g of x less than or equal to 16. Finally, we're asked to find the range of f of the inverse of g. So remember, for this, we actually find the inverse of the inverse of g first, and then whatever we get out, we then put that into f. You work this way. So we're putting in x into a function machine, and we're getting out the inverse function. We're then putting that into f of x, and that is what's going to give us f of the inverse function. So we actually don't need to think about the values of x that we put in, the domain of the inverse, although I'm going to, because the domain of the inverse is the range of the original function, so 0 to 16. Okay, this bit is not vital, but let's just go with it. That would be the original domain. The more important thing is the range, which we worked out in part C. So I know when I put it in, I'm going to get values between 0 and 4. And it's these values that I'm then putting into f of x. So now there's a restricted domain on that. Originally, it could just be anything, well, it had to be greater than minus 3 over 2. In fact, that is still the case, but it's okay here. But if we did have like a negative here, we would have to respect that. We'd have to make sure we only include the negatives. In fact, I think you'd say that it's not defined technically, wouldn't quite be compatible. So, right, we can either use this, actually, I am going to use this f of x, I think. Could use the original one or this one, but I'm going to be talking about a sketch in a minute. Okay, now this question, for the purposes available, it's enough to kind of just put in the endpoints, put in 0 and 4. And if you can look at this and say that, yep, I know that this is just going to be a decreasing or increasing function, then you're absolutely fine. And you kind of know that because this is a reciprocal function, and reciprocal functions are, well, they don't kind of go up and down. I'll talk more about this in a minute, but what I'm going to be doing is finding f of 0, which is just going to be 4 minus 7 over 3, which ends up being 5 over 3. And then f of 4, this one's a little bit trickier, so 4, I mean, okay, you got your calculator, so 7 over 11, which ends up being 37 over 11. And the final answer is then 5 over 3 less than or equal to the inverse of g less than or equal to 37 over 11. Okay, so just a reminder, we've put, well, okay, this bit was really not needed, but we've got out values from the inverse between 0 and 4. They're the only ones we can now put into f. We're okay because f is defined over all x greater than minus 3 over 2, so that's satisfied. But now we've got this restriction, has to be between 0 and 4. We put in the endpoints knowing that the function doesn't kind of go up and down. It's not like some sort of cubic where you think, right, I'm gonna put in a point here and maybe a point here and say, that maybe that was my restricted x, and then say, oh, it's going to be, but this is my range between these two values because we've missed this point here. It's gone above and back down. That's what I'm trying to say. But we're okay in this case because it's like a reciprocal, and that's why we can check the endpoints. And let me just show you finally a little sketch of the actual function. Got a graphical calculator, you can actually sketch it out. But if not, this is what we're going to do. So I am going to look at the negatives as well. Okay, so first up, we know, oh, it's a minus. So we know that minus 1 over x looks like this. And even this would be minus 7 over x even. Then I'm kind of doing a stretch and a translation here, but I can see that it's not going to be defined when x is minus 1.5. So I can just, it is ultimately going to be kind of this sort of translation and stretch. Minus 3 over 2. At the moment, the asymptote would be y equals 0, but when I add 4, it's going to move on up to 4. So that's what the function is going to look like, thinking about the transformations. Um, although it should have moved up even more because I know, sorry, let me move it up to there, because I know when when I've got 0, that should be getting 5 over 3. Okay, that's more accurate. So I've got my 5 over 3 here. I'm actually only interested in values between 0 and 4 for x, so this does not exist in my function, this doesn't either. And what I'm doing is finding this value here, at 4, and that's where the 37 over 11 comes in. In fact, if we had x approaching infinity, it wouldn't just continue to increase, it would actually tend towards 4. But we don't have to worry about that here. But back to my original point, we can see the function is actually increasing over this interval, and that's why we can use the endpoints. The left-hand one, the right-hand one, it's going up. It's not like it goes up and then back down, in which case we'd have to find that maximum to increase the range. That was my point, but all I'm going to say is like be careful um, in general when you're dealing with like the range of functions like this. Okay, well done with this question. Hope you're happy with it.